Hello CAD 1. I am going to quickly give you a demonstration on how to create a tube rivet. A couple of you have cut your acrylic in a way that you want to create a hinge for like wings or a butterfly, some movement. What I have here is an example of a silver tube rivet in copper, and there are two of them. I have a tiny one and a larger one. And that's in metal. It's the same principle. I'm also going to demonstrate it in acrylic. Here's an example of one that I created already. You can see that the copper tubing, and this is the exact tubing that I'm providing to you guys. There'll be some in the tool room. I'll have details about that. I'm going to leave it in an envelope in the tool room, and if you and I'll have it cut in small pieces. You are still going to have to cut it yourself somewhat because the length of each piece of tube will depend on how thick is the pieces that you are riveting. So there's that. So I've got a piece here of acrylic sheet, and this is what I'm going to use for the purpose of this demonstration. Okay, the first thing we're going to need to do is measure the thickness of, we're going to have to figure out how much tubing we need. So you're going to need to borrow a set of calipers out of the tool room if you don't own your own pair, your own set. We have digital ones in the caliper, or digital calipers in the tool room. I use a not digital one because, I don't know, I'm old-fashioned that way, and plus I can't find my digital calipers. So the first thing you do before you measure anything with calipers is you should zero them out. When it's closed all the way shut, your dial or your reading should say 0. And you open it up, you can see that it opens and changes the numbers. So I'm going to be using this piece of acrylic, and I'm going to very carefully break it down here because I'm going to put a hinge in somewhere here. Okay, so let's say I'm going to put it here. I will get a Sharpie. But in the meantime, I'm going to measure the thickness of what I am putting together. If you're doing multiple pieces that are a lot, you may want to measure them all individually and write it down. But whatever you do, you write it down. So let's just measure one piece. And this is 0.092 thickness. I'm going to write that down. 0.092. We'll check the other piece too, just to make sure it's the same. It should be 0.092, and it is. Yeah, it's tough with our. You can see that the caliper hasn't quite reached the 1 on the length of the caliper, but there in the dial you can see it went to 9.2. So if we remove this and let the dial go all the way back to 0, it will not have passed 0. So we know that it's 0.92 times 2. So 0.092 plus 0.092, the thickness that we're going to need is 418.184 is how much tubing we'll need to get between there. But if you look at the tubing, if you look at the rivet here, okay, you can see that it has kind of a lip on the top. All right, so it needs extra. So how much extra does it need? Sometimes you just cut it and then you play around. You get a good feel for how much extra tubing you should have. But I like to go by Tim McCrete, Crete, I'm not even sure how to pronounce it. This is a great book if you don't already have it. If you're only going to buy one book to start with your jewelry journey, this is one that I would highly recommend. It's very simple explanations, sometimes not as much detail as you want, but you know, we have YouTube these days too. So what he recommends when you're cutting this is, I thought somewhere he said that you want to have it longer on each side by half the diameter, half of what the diameter of the tube is. Where did it say that? First step is, okay. So, I just want to figure out the length. So that's what we're going to go with, though, is half the diameter. So how big is our tubing? Here's a piece of the tubing here. This is a real long piece. Let me find a shorter piece. Yeah. All right, so here's a shorter piece. I don't know how well you guys can see this. So I'm going to measure the outside diameter, and this is 0.114. And that's the outside diameter, so half of that, 0.5 times 0.114. I, of course, do not have my calculator, but that should be 0.057. So that's how much extra. 0.057 is about here. That's about how much extra we want on this length. But we need that on both sides. So really, as long as we know what the diameter is, we can just add that amount to the tube. And realize that I'm doing that because you have two ends. So I need 0.184 for my thickness, and I need 0.114 for the ends that are going to be flared into the rivet to hold it in place. So we've got 8 and 8 is 4, 8 is 9, and then, so it's 0.298 is how much tubing I need to cut out of here. So 0.298 is almost 0.3. This is 0.3 here. So I need a really small piece of tubing. We'll cut that. Okay, I've adjusted the camera a little bit so that we're a little closer here. And again, I'm going to measure the tubing. So the tubing is 0.11, almost 4. I've been estimating these to you guys who have been designing for these rivets in CAD as 0.115, so you're real close. Again, we realize that the length for this is going to need to be 0.298. That's because we're going to add the diameter of the tubing as well as the thickness of our acrylic, right? So we've got that, you know, times 2. The thickness of our acrylic times 2 plus the diameter of our tubing is 0.298. We're going to give that a tiny bit of cushion. Obviously, we'll go up to like 0.3. And here we go. I'll show you right here. Up to about there. Our caliper is almost at 0. And I'm going to hold that right there. That's one thing I like about dial calipers. I feel like, you know, I can really set them where I need them to be. So this is how thick we need, how long we need to cut our tubing. What I'm going to do then is use a set of dividers. I've got my oh so ancient dividers. I've had these for about 1,000,000 years, and so I'm going to match those up to the opening of the caliper. I can also do it here. A lot of calipers have these marks slightly indented, and there we go. So I've got 0.3 here in the calipers in the opening. And what I'm going to do with those is I'm going to mark my tubing right here. I'm going to just hold it at one end, and we're going to rotate the piece of tubing. Okay. And there we go. That's how we've marked it. So we have some of these nifty little tubing cutters in the tool room. Let's see if I can adjust this light a little better here. Maybe not. So we have that little scratch there where we wanted to cut the tubing. We're going to put that just slightly. Our saw blade will go through this straight across. You can see that you could also miter how you cut tubing using these tools. To be honest, they're not super great holding most tubing, but they're better than trying to hold it with your fingers. There are some other methods for cutting tubing, but this is one that I use. So we're gonna go and we can just set it there. See how it's kind of a little bit where the slot is slightly on the outside. So I'm going to tighten this here. So now when I push that tube in and I hold it in place, it's just going to stay there. Okay, so what we're going to use to cut the tubing is a jeweler's saw. A jeweler's saw will not collapse the tubing. We can't use anything like cutters or you know, wire cutters or anything that's going to squish it. We can't use a shear. What we have to do is saw this tubing to the length that we need. So we're going to use a jeweler's saw. You probably have seen these around the studio. If you haven't, I know some of you guys are completely new to jewelry, so you may want to ask a monitor if they can help you a little bit with the saw. But what I would recommend is that you use a 3/0 saw blade. It's a pretty sturdy size, and it's you know, you can see the teeth really well. Let me see if I can get this to focus on the teeth. Maybe not. Here, let's try putting it in front of the white here. So we've got, yeah, here we go. Maybe not. Oh, yeah, here. So now you can see these teeth. So the teeth always have to face down. You hold the jeweler's saw from the bottom, and your teeth should face down towards the handle. Okay, this is how you hold it. And so my teeth on the saw are going to be on the outside of the saw frame and facing down. So one way, if you're not sure, is you can touch them a little bit with your finger. You can feel one way is smooth and the other way will resist. So I usually put it in the top part of the saw frame first. I'll rest my frame, my saw frame, in the thing. Right now I'm pushing against it with my stomach. So I'm tightening. Now these ends are just clamps. Maybe some of you have used a coping saw before. That has a different kind of blade. It has pegs that fit into a frame, and then you tighten the frame on the outside. A jeweler's saw is actually composed of two clamps, one at the top, one at the bottom. They have a little bit of texture usually inside the teeth, and but mainly your saw blade is going to go in there. But I put in the top one first, right? So this is tight, this is nice, it's pretty flush. You can see, you know, sort of how it's just, you know, in there. But now let's look at the other side. The other side, see how it doesn't go all the way to the bottom. So you may say, oh, well, I should change this end. No, don't. You want it to be about halfway through here, right? That's where you want your blade to fall before you tighten it in the bottom. But what you were going to do is we're going to push against the saw frame. And you're going to see how when the saw frame is tightened and pushed, right, it's going to, like, this end and this end are going to be, let's see if I can push together. And you see how the frame has a little bit of a spring to it. So we push this in, and then when we push it in, you can see that the blade now goes to the bottom of that clamp area. Push it in between the two pieces of metal and tighten the thumb screw. Okay, and now that is a really tight saw blade, and that's what you want to saw. If your saw blades are too loose, they break all the time. They break anyway. Saw blades, jeweler saw blades, are considered consumables. But you can see here that our teeth are facing down. There we go. And our saw blade is nice and tight. Okay, so let's get back to this contraption. Again, remember we had our tubing marked. We're going to put that here. And you see this little thing? We're going to hold it down, and we're going to hold the whole thing in one hand. And then we're going to take the saw blade and the saw frame and go into that straight, and I'm just going to saw very slowly, very carefully. I'm actually going to stop for a second. I'm going to keep tension on it with my thumb here, and I'm just going to rotate it a little bit so I don't have to go through the entire thing all at once. The blade does rub a little bit on the sides of this, and this piece is made out of steel, so it does mess with your blades a bit. And so if you have trouble starting it, just push first, you know, go against the tooth. Okay, I'll turn it again. Just a little bit, and we're almost done. All right, so that's one, and it's cut. You can see we cut this tiny little piece of copper tubing, right? Now, is this the only way to do this? This thing is a little bit tedious to hold. Another way we could do this is with a file jig. We have these in the tool room as well. All these tools we have in the tool room. You can borrow them from the tool room, you can go in. So what this what this tool does is it will hold tubing and wire for sawing and filing. So if we again, so my dividers here are still set to the 0.3. So I'm going to mark another one here. And we're going to cut a second tube, because I'll try and do this twice for this demo. So there we go, I marked it. So we have this guy here, and what we're going to do is we're going to put this in between two of these parts. So this separates, it'll hold tubing at a certain angle. If you need to cut to a 45, or I believe the other one's a 60 angle, we have a 90-degree angle, which is what we're going to use, and we have a 60-degree angle. So these are great for making mitered parts, you know, like the edges of a frame. But you can see how they all just like stack up. So what we're going to do is they tighten up with these screws on the end. These screws here, don't mess with them. But so I have it open a little bit. I'm going to find that marking. There it is. I'm going to go down here. We're going to just slide it in and see where it fits. Again, I'm going to cut it outside of my mark, so it's a tiny bit longer. I'd rather have it a itty bit too long than too short. So now I'm squeezing it in the middle, and I'm just tightening these screws on either side. All right, so now the file jig is holding this. Now I could do the same kind of thing as I did with the other one, although to be honest, I usually have to do it this way because the thumb screws on the jeweler saw get in the way. So this is a little awkward to hold too, but it feels a little bit sturdier sometimes, and you may have a better feel for it than the other way. Okay, I'm going to just turn this a tiny bit. Now, I'm cutting, but understand this, this blade, be very careful. Keep your fingers outside of the V. As long as you're working on the V, on the bench pin, you shouldn't cut your fingers. So I like to like hold it like here. And you see how my saw blade is within that V on my bench pin. As long as I'm working in there, I shouldn't really hurt my fingers. Even if I go straight through this tubing here, and there you go. You can see the tubing starting to come off. There we go. It fell on my little bench pin there. Hey, couldn't do that again. Now, if I was cutting this and was using this tubing for something else, this would be a great time to file this. I could just grab a file, and these are made of tool steel. Should be really hardened tool steel. Some are better than others. We have some pretty good ones in the tool room, but you can file this flat and you can get a real nice a nice, perfectly perpendicular finish on that end. Of course, that isn't what we're trying to do. That's actually our extra tubing here. And the pieces of copper tubing that I'm going to leave for you guys are going to be about this size. I don't want to make them so small that they're hard to handle, but I also don't want to give you, you're not going to get a whole like big 12-inch piece of it or anything. So this is a file jig. We have several of these in the tool room. Very, very useful tool. Okay, so now we need to find we need to get a drill bit that matches our tubing. So again, this is where our calipers are going to come in handy. If you take your calipers and go into the tool room, there are plenty of drill bits behind the door. You can ask the monitor to help you. Oh, my calipers were still locked at 3. I'm going to loosen them up. Okay. And so if I measure this, this is the tubing. Again, it was 0.114. So I've got a drill bit here that I happen to know fits. I don't know what number it would be for the tool room, but this drill bit is 0.117. So it's 3/1000 of an inch bigger. We generally want it to fit perfectly. So let's see if this is close enough. So I'm putting the drill bit into the drill here. Okay. This is not the same drill that we have at school, so you may need to ask the monitor to help you put the drill bit in. We may be able to set up a time if I get a chance to come in. So I use scrap pieces of wood here. This is a very small drill. I feel comfortable hand holding something small like this piece of plastic. But remember, if anything you're ever holding for when you're drilling, you should be prepared to let go of it if it seems like it jams in the drill bit and starts to spin. So I'm letting this go, and I'm bringing the drill bit down. And notice I'm doing it in small little increments. Okay, until I go through and I have a nice clean hole here, I'm going to shut this drill off. Okay, woo, there we go. Let's try and there we go. There's our hole. Reasonably clean. Let's check it with the tubing. So this is our bigger piece. This is, wow, look at that. That's pretty good. So that was just a tiny bit. It was 3/1000 of an inch bigger. And you can see it moves pretty well. That's not bad. Not bad at all. I'm going to drill again, just so you can get a better view of this, maybe a little bit closer. Let me see if I can move this drill a little closer. This is a different drill than what we have in school. So I do want you to be aware that the drill we have in school is a little more sophisticated. You have to actually tighten, you finger tighten the drill bits in place using your fingers here. You hold it still in one spot and then you tighten the top part of it. So we figure out where we want the hole, and this is where it'd be helpful to have a Sharpie. I'm going to, now some of you marked your acrylic with the laser, so you know exactly where that rivet needs to go. What I would suggest is practice on a piece of scrap first. And I also suggest that, you know, everybody should have enough copper to make a practice rivet first. And that way you can see where the issues are. The first time you make a rivet, it's not going to be perfect. So I always recommend that you do a practice. So one of the things about drilling plastic is you don't, well, I think actually one of the things about drilling in general is you don't want to overheat. If you overheat your bit, it'll break, it dulls. If it breaks, it could hurt you. Don't forget, you should be, I'll take them off now, wearing your safety goggles. Everything that you do in the MJCC studio, you should be wearing your safety goggles. So I'm going to turn this on. We're going to go down. And as you can see, the bit is just touching now a little bit. I pull it up, a little bit down again, pull it up again. If we run it straight through and it generates a lot of heat, these little bits can end up melting onto it. You want to try and keep both the bit and your piece that you're working on cool. So we've got 2 holes here ready for our rivet. And this was a test piece just for drilling, but here we go. We're gonna, let's have this hole here attached to, yeah, let's do it here. Let's just have it cross over here. All right, and so I'm gonna mark on the other skinny piece where I want this to go. I'm gonna put the hole right here, and we're gonna drill another hole in the acrylic. All right, here we go, right in. I always line up where my drill bit is gonna go before I turn on the drill. Okay, all right. We go up and down, clean it. Nice clean hole again, there we go. Great. So we've got our holes drilled. Okay, so we're back to the bench pen. So we've got 1 hole here. There we are. I get used to where the camera is again. All right, so here we go. And I'm going to use that little paper pad here. So we've got a nice hole here. And we actually have 2 holes in this piece of plastic. So we've got a choice here. And we have the little rivets, right? Our copper tubing. And I cut 2 of them so that we have a spare. I like to cut an extra one because these things are little. If you drop them on the floor, I mean, gosh, look at my bench pan. If I lose it in there, it might be going forever. So let's make sure it's going to fit through both of these holes. We're going to line it up, put it in. There we go. That looks pretty good. You can see how much it has on either side. And yeah, there's a little bit of light. But yeah, sorry, I'm trying to find a good focus point. All right. Actually, here, I've got my little magnifying glass to show you. So you can see it's just sticking out a little bit on either side. And I think that when you use the diameter of the tubing so that it sticks out, you know, half of that on either side to add that to the thickness, that's a pretty good measurement. So how are we going to start to get this to flare and, you know, create this nifty little lip that we have in this other one, right? We've got that there. We're going to start with on your bench block. Now, I don't have a bench block here. I have this little bench anvil. Hang on. Now, this is a pretty nifty contraption. If you're just starting to set up your own studio, this is a great thing to have because not only is it a nice, flat, hard tool steel surface that you can flatten things on like we're about to do, but it also serves as a bench pin. You can see if we put the bench pin that came in with it on, and you can clamp this to your table. All right, and you can see I've got a nice nifty little, these are not expensive. They're less than 20 bucks. At least they were the last time I checked, which was only a couple of years ago. But this is a really great tool to have. This one I have here, I have had since 1984. So it's an old piece, but these things, they don't go bad. I mean, they can get little nicks and stuff. But so what we're gonna do, so the whole point of doing this, and in the MJCC studio, that big flat metal piece in the middle of the benches is a bench block. That's basically an anvil at your own, everybody's got this at their desk. So what are we gonna do to start widening this out? Well, there are a number of different tools you can use. Some people, you know, just like gently start to open it up with a tool, kind of like the dividers. These don't go all the way through and they might round it out. I like to use this center punch, and we have center punches in the tool room. And I'll take that and hang on, let me get the hammer that I have. It's, for this kind of stuff. So this is kind of just a crappy hammer that I use for banging on tools. If you get any hammers out of the tool room, like there are riveting hammers, and I'll show you a chasing hammer is what I'll finish this with, or you can use a ball peen. We have some small rivet hammers that have peens on the end. This is a peen, this rounded end. Make sure that you're using ones that are green if you're going to hit tools. If it's red, then that means that you can only hit soft metal with it. You cannot hit tools, other steel, because you will ruin the face of it. You can see that the face of this is a mess. That's because I hit tools with it. So what I do with this, and again, you can see I've got like a real sharp angle on it. We just start to bang in from one side. Sorry, the tripod that the camera is sitting on is on this bench. All right, so then we flip it over, keeping it all together, and we're going to do it again. All right, let's take a look at that already. So you can see that it is already, and let's do it this way. It is already starting to flare just slightly. All right. So we're going to do this a few more times. Notice I'm tapping very gently. Remember, this is plastic. And, you know, most of you who have, you know, when you designed this, I was trying to tell you to leave plenty of room around where the rivet was going to go, because that will weaken the integrity of the plastic, and it's very prone to snap if you hold it too tightly. So here we flipped it over. Let's hit it a few more times on this side. And this is what we're going to do. We're just going to keep doing this for a little while. Just a couple of times on each side, maybe 2 or 3 or 4. All right, so now it's starting to get definitely larger on either edge of it. Here we go. So you can, I don't know how well you can see that. All right, but you can see that the top of the rivet, and you can see it's now holding it in place. Now it wouldn't hold it forever, because if this plastic, you know, it's not tight enough. There's a lot of play in between the pieces, so we need to make it tighter. But we're not going to keep using this, because if we keep using this, we could split the tube. So now what we want to do is we want to go find ourselves a dapping punch. We have piles and we have a whole bunch of these. They're a punch that look like this. They look like giant tall metal chess pieces, right? And what we want to do is find really small ones. I have a set here. So let's go with something like this small, or I even have something smaller. Here we go. So if we take this little guy and just put it right in the opening in the top of the rivet, hit it a little bit more, and then flip it over. This one actually is a little teeny bit small. I'm only going to hit it once with this on both sides. So you can see how now you can see how it's starting to really flare it out nicely now. Now that was this one that we just used. Now we're going to move up to this one. I don't see one in between. Let me see. I have a couple extras that I inherited from somebody that don't really fit with my set, and I think this is one of them. All right, so I'm going to do this again. Now I'm holding this right on top of the opening. See, it's like we're nestling that ball right in the opening of that tube, and we're going to hit a few more times. And the trick is not to try and open it completely on one side before you flip it, because you want it to be even. Sometimes it will start to angle on you a little bit at this stage. So you just want to try and do it pretty square. You want to try and hit these things nice and square. If you have a lot of acrylic here, you might want to put some extra things under it to keep it stable, so that it's not going to have a lot of stress while it's getting beaten here. I'm gonna hit this just a little bit more. We're gonna hit it a little teeny bit more here. Again, I'm gonna support that loose piece. And I can see it's starting to angle a little bit, so I'm gonna try and work against how it angled. All right, so you can see here it's definitely gonna hold it in place. You can see how flared it is at the tops. Let's get that to focus. This is hard. Okay, but now I'm gonna go get. I have a little hammer here that I use. This is a peen here, and I've got it. It's a little flat there. We'll use the flat just a tiny bit at the end, but so now we can start hitting it with the hammer, and you're gonna hit it really slow, trying to hit it sort of in the middle. And as you hit it in the middle, you're going to slowly work around the outside. You're going to hit it in the middle and kind of come off on the edge. Sort of like as if this is the, the top of your rivet, you're going to hit it like that and kind of move it towards out from the center. This is kind of a big peen for this, so I'm going to get a chasing hammer. Here's my chasing hammer, and I'm going to, I hope you can see this, guys. Again, all right, you can see how that's coming together here. And the other side, we still have to do, see how the edges are still kind of sharp there. We're going to start to smooth them out. Like I said, hit it in the center and then go a little bit towards the edge. All right, so that's not too bad. This doesn't have a lot of play in it. It has a little. So I want it to, it depends on how freely we want it to move. Like at this point, you've got a lot of movement. But if we continue to tighten this up, it'll get to the point where it doesn't move at all. If we continue to tighten it. I actually liked how this guy was doing, so I'm gonna try and smooth around the edge. Remember, really slight taps. Oop, and that was my soldering pan that I had sitting on top of my rinse bowl. All right, so now you can see it's not going around quite as easily. And now I'm going to use this flat part just a tiny bit. And we're going to do it over. Oh, wait, this needs a little more rounding out. Okay. Hang on. There we go. All right, so that's pretty much a tube rivet. All right, and this still has pretty good movement, actually. We could, so one way too that we could tighten this just a tiny bit more, we could go back to that center punch and hold it against one of these dapping punches, and we can actually just hold this in the air and try and tighten it from both sides just a little bit. That'll help. That tightens it a tiny bit too. Now, take a look. Actually, this acrylic was pretty scratched to start with. But what I would suggest is that you be careful handling your acrylic. Acrylic scratch is super easy. So, yeah, that is a basic copper rivet. Okay, since we have a spare rivet, we're going to do this again, just so everybody can take another look. If you, maybe you might get a better angle than the last time, so I'm going to try this again. So, all right, we're going to feed the rivet through one thing of the plastic, the other thing of the plastic. I'll go over the math again one more time before I finish the video here. So the first tool we're going to use on this is a center punch. It's a big center punch. It's actually, you know, although it has a really fine point, it's great for jewelry, and often I don't even need to use tools with it. I could even start to just this rivet this way, but I like the angle on this, and it's always worked well for me too if I just hit it. So I get my little, again, this is my hammer that is okay for hitting tools. So I'm going to go over here and unfortunately I'm in the light. There we go, that might help. Still getting the hang of doing these videos from home. So we got this, we'll flip it over. And I'm going to hold it up so you can see that. Now, the beginning is when it's most likely to angle. So you want to make sure that you're hitting it nice and straight on. It's hard for me to hit it real straight on with the camera here in the way and the tripod. Let me see how best to hold this here so you can see. Okay, good. And I'm trying to hold this nice and straight. So just a couple of hits on each side. If you can keep things well supported, you should. If you only have a little piece in the back and you have big pieces on the top, do something like grabbing a spare piece of acrylic and put it under and make sure that your pieces are well stabilized and supported, because if you're banging here and you hold something, you can so easily just break something. So keep your work supported. Just gently. Again, I'm going to support the unsupported part. If I have it in an X like this, then these parts here are not supported unless I have something under it. Little scrap pieces of wood. We have plenty of scrap acrylic too, usually laying around in the wood room. You can ask some of the upperclassmen or the grad students if they know where you can get some scrap. So I'm just, and you can see now, this is starting to widen up a little. I'm going to show you here with the magnifier. So these ends are definitely widening. See how that is? And you can see it's starting to flare from the inside because we've been hitting it from the inside. We're not trying to, squish it necessarily on the top, but we're trying to stretch just the inside, stretch it from the inside on the ends. So at this point, we're going to stop using the center punch and we're going to go ahead and use a dapping punch. Now remember, like I said, I have, we have whole sets of these. See, there's like tons of them. We've got a whole set of them in the tool room. And go in and find a nice small one that'll fit in here. I've got 2 of them, and 2 is good because, 3 might even be good too if there's like, if you could find one in between like this size, which I don't have one in between this size. I have this tiny one and then I have this next one. I start with the small. If I had one in between, then I'd go a couple there and then I'd go to the bigger one. But you want to start with a small one. This one is almost too small. My phone's doing low power mode. And we're almost done here. We're going to go here. And we'll do this one more time on each side with this guy. Not very much. He's kind of small, but we really want to make sure that we're stretching it from the inside of the tube. The metal's moving. One of the fun reasons to do this in copper. Copper is a nice soft material. If you were to do this with sterling silver tubing, you would have to anneal it first. So we're going to hit this a couple more times here. And you can begin to see definitely that, and it gets shiny too because you're hitting it with these smooth metal pieces. So I've got to go back to this one, I think. All right, and we'll hit it again. And we are almost ready to hit it with the hammer. So now I'm going to pull out the chasing hammer. We have small rivet hammers. We have smaller hammers than this. This is just what I have here. But you're going to want a hammer with a small peen on it. And you can see that's only about the size of my fingertip. And we're going to use that. We're going to kind of hit in the middle and let it sort of bounce to the side. So it's like if this is the tubing, we're hitting it in the middle and sort of trying to go away. We're doing this slowly. We're not gonna, you know, the point is not to spend a lot of force. You can see that I'm only picking this hammer up like a couple inches. These are tiny rivets. And we also don't want to damage the plastic, which is one of the reasons that I really like tube rivets. They don't need as much force as, and you can see that I'm already starting to round it out. Let's do the other side. Same thing, hit in the middle and then go towards the outside. Hit in the middle, just kind of around the outside a little bit. Hopefully you can see, oh yeah, that's a better angle there. All right. Now I do have that other hammer of mine that has a, you know, that one's a little bit bigger. We can hit that a little bit. And I'm sort of just going around it rather than necessarily going into the inside. And you can see that this one is coming together tighter than the first rivet that I did. And probably because I took it a little slower and decided to go a little more with the, so now we have, this is a more controlled kind of hinge. And for those of you who want your piece to like be able to be moved and stay in place, this is more like what you want. And we're going to look a little bit at what the profile view, the side view of this looks like. Let me see if I can get a good focus here. See how it still has kind of sharp edges? And you'll feel those if you run your finger over the rivet. You could say, oh, okay. Well, you don't want it to have that. So we're going to have to still smooth those out a little bit, probably with the smaller peen here. I like the end of a chasing hammer. It's nice and small. I think we have in the tool room small hammers with little peens that are like smaller than this. Okay, so that's definitely getting better. And this is most certainly still has free movement, but it's really definitely a more tight fit than the other one. So we're gonna, and anything we do on one side, we really should do on both sides. Now here, you can begin to feel that that's not catching as much. It is catching a little bit there, so I'm gonna try and get that spot down. Now you can almost work on the sides of it. Just, again, you can see I'm not using a lot of force. This is copper, it's a soft metal. Don't need a lot. There we go, that feels pretty good. Here's another one. All right. Now, what I'm gonna do is these samples that I made, I'm gonna leave them in the envelope in case anybody wants to pull them out and take a look at them. Along with several pieces of copper. This one is looser. This one is more for something that you want to be able to move freely on its own. This one is a little tighter, so it'll hold in place. If you like have it like this and you want to just move it and have it stay, this is a tighter rivet. Okay, I just wanted to real fast go over one more time the measurements. So this tubing that I'm providing for you, if you use anything different, you're going to have to remeasure and figure out this math on your own. But the way that we figure out how much tubing to cut is the first thing we do is measure the thickness of what we're riveting together. And we could either measure those things together like this, since I've now riveted it. And I like to measure things that are flatter, more towards the middle of the calipers. You can see here that it was 0.18, well, 84. which is actually exactly what we measured it earlier. You know, 0.092, 0.092, 0.184 was the, this is the material thickness. And then this here is the tube width. The outside diameter of the tube was 0.114-ish, a little bit below that. So we add that to that, we got 0.298. So we decided to just move it up a little tiny bit, and we decided to go with 0.3 for the total length of our rivet, and they fit perfectly. So what I used was these dividers, and I put them onto the caliper here. You can see they're like just about 0.3. I used those to measure the tubing. Okay, I cut the tubing with a jeweler's saw, and either the tubing cutter, which is a little awkward to handle. You have to kind of hold the tubing and stuff in your right hand, hold it to the bench pin, you know, like against the bench pin like that while you're sawing. It's a little bit awkward. And the other tube you could possibly use is a filing jig. You can open it up enough to fit the tubing in there, bring it to the mark, cut it just outside the mark. Like right about there. Oh wait, not those. These get tightened from the bottom. Okay, and then you cut it here. So, and then we fit the tube between in the hole, and then that's the other thing. We're taking that measurement of the tubing, and we're going to take our our calipers into the tool room and make sure that you have a drill bit that is a good size. The drill bit that I'm using was a little bit bigger. It was 0.117, and the tubing size was 0.114. And as we saw, it fit perfectly. And here's just a single hole, which I'm going to leave in that sample. Again, this is all going to be in the envelope that I'm going to leave in the tool room, which means that you can only do this work while there's a tool room monitor. Okay, here we go. Again, give me a call if you need any kind of help while you're in the process of doing this. And I may be able to set up some times if you really need me to come down and walk you through it.